ladies and gentlemen. Piecewise functions. Here we go. Now, the reason they are called piecewise is because they are broken up within their domain. So notice, in this situation, how many different pieces do you have?
3.
You have 3. So in fact, I'm going to start with this first function where x is less than or equal to -2, which means -2 is a breaking point. Now, who can help me understand what does it mean when it just says 4?
It's a straight line. It's straight horizontal.
Yeah, it's just a horizontal line. Now the question is, do I include the -2 or not?
Yes.
So I do. So at -2, what I'm going to do is I'm going to go up to 4 and I'm going to fill that circle in. And now because it's less than, that means my x values are going to the left. And it looks like this. And I'm going to put that arrow there to signify, why is this not? There we go. To signify that's what happens when it's less than or equal to -2. Now look at my second function. It is what? It is x plus 2. It is linear. It's between -2 and 2. So the question is, what happens when I plug in -2 here? What do I get? So just to help me understand, I'm going to get -2, 0 on my left. And what am I going to get when I plug in 2?
4.
You're going to get 4. So, okay, what the heck? I know. Okay, there we go. So, here we go. At this point, please notice I'm going to fill this in or not fill this in at -2. Not. So I'm going to go to that ordered pair, -2, 0. It is going to be an open circle. I'm going to go to this other ordered pair of 2, 4, and it is going to be a closed circle because it says to include it. So far, so good? Now, what do I do in between there? You connect it. It is linear. And happen to notice, what's my y-intercept? +2, which is what I was anticipating because that's what it said. Okay? Now go here. Go ahead and plug in 2. As I plug in 2, what's the x value we get? 4. And then what's happening as I graph this? My slope would be going up 1 over 2. So I'm going to go, oh look, it's already graphed, right? So there's my point. It's at 2, 4. I'm going to go up 1 over 2, and I'm going to use that slope to help me create my line. And therefore, you have just graphed that piecewise function. Okay? We good? Okay, so we're just remembering how to graph these right now, okay? So let's try number 2. Go ahead. Now, I like to put my ordered pairs there. I don't know how you guys learned that, but I feel like it helps me understand it a little bit better. Okay, so look, if I plug in -1, what value do I get? 2. So I'm going to go to -1, 2. Is it going to be open or closed? It's going to be open because it just says less than. It doesn't say equal to. And if I look at that slope is positive, but it's a 1. But realize we're dealing with less than -1. So I want to be going to the left. I need a slope of +1 that is less than that. Okay, so there it is. You guys good? You having a flashback of piecewise functions? Sorta, kinda. Okay, go ahead, plug in -1. Tell me what you get. You get 2.
Have my guys already seen you?
No.
Okay, I'll come back in a few minutes.
Okay. Go ahead and plug in 2. What do we get?
5.
We get 5. Okay. So at -1, +2, is it open or closed? It is closed. Weird, that circle that I made is now closed. But realize I'm dealing with that second piece. Now I'm going to go to 2, 5. Is it open or closed? Open. Now guys, this is not linear, so do not draw it linear. What is this? This is quadratic. I have a y-intercept of 1 that kind of helps me out, and if I wanted to plug in 1, I would happen to get 2. So that kind of shows me what that quadratic is doing. Okay. Now between 2 and 4, again, there's still 2 ordered pairs. So as I plug in 2, what do I get? Well, there's nothing really to plug into, but I am going to get the number 5 because it's horizontal. What happens when I plug in 4? You're also going to get 5. Well, just think about it. It's 5 plus 0x. It's still linear. You just don't think of it as linear. Okay? So at 2, 5, is it open or closed? Closed. Again, I'm filling in that circle. Weird how that's working. And then at 4, 5, is that open or closed? It is open. So I'm going to draw the horizontal line that connects them. And then last but not least, let's go ahead and plug in that 4, and what do we get? We get negative 4. Am I going to fill it in or leave it open? So 4, negative 4, I'm going to fill this in. And be careful, guys, what's your slope? Negative 2, so that means I'm going to go down 2 over 1. And then I'm going to draw that arrow. Okay. Now we're going to use these in a minute. You guys good on how to draw that? Yeah? We are? So guys, the reason we're looking at piecewise functions is because we're going to define continuity. This is one thing that will never, ever, ever go away. In fact, the sooner you learn this definition, the sooner it's going to make your life easier. Okay? So let's define it. What does it mean to be continuous? Okay? Rule number 1. The limit exists as x approaches c. Now guys, c stands for constant. It has to be approaching some value. We just call it c because it's always changing. We've had it defined as 0, as 1. We've plugged in maybe a negative 2. Okay? C is just a fancy way of saying some constant in this case. If you need to write that down, write that down. Or you guys can refer to this video later on. Okay. Next, f of c also has a value. Okay? That means that also needs to exist. So the limit has to exist, and when I plug in c, that also has to exist. Now here's where it gets tricky. Well, not tricky, but necessary. The limit as x approaches c of some function needs to also equal f of c. Okay, think about what I just said there. The limit as it approaches c has to equal the value of when you plug c in. That is continuous. So, first of all, we're just going to look at some of these and we're going to decide, are they continuous or not continuous? If it's continuous, it has to satisfy all 3. If it's not continuous, it just has to break one rule. If it breaks one rule, it's out. Okay? So, in letter A, as we look at this function, is it continuous or not continuous? This one is continuous. Okay? Everywhere. So this is continuous. Okay? In letter B, is it continuous or not continuous? Okay? It is not continuous. In fact, if I wanted to put some value on it, let's call this 2 right here C. Okay? If this is C, does C have a value? Yes. But does the limit exist at C?
No.
No. Therefore, you broke one rule, it's not continuous. Yeah, honey? Yeah. Okay? Letter C. What do you guys think? Continuous or not continuous? Not continuous. Raise your hand if you can tell where you want C to be so that you can prove that it's not continuous. At 4. Okay? What rule does it break?
The third one.
It does not have a value defined at C. Okay? It does not have a value defined at C. So again, this is not continuous. So far, so good? Okay, look at letter D. What do we think? This is not continuous at 4. So again, there's an asymptote there. Anytime there's an asymptote in your graph, it's not continuous. Letter E. So if we're struggling with this one, let's see if it breaks any rules. Does the limit exist everywhere? Okay. Is there values of C defined everywhere? Do those limits match those values? Yes. So therefore, this is continuous. Letter F. So let's see. So what value of C do you think we want to look at? We want to look at 5. So let's go through this. That's where C is. Okay, so does the limit exist at 5? Yeah, what is it? Looks like maybe like 3.5. Okay. What's the value at 5? 6. Do the limit and the value match? It breaks apart. 1 and 2 work. However, it breaks apart if they don't match. So this is not continuous. Okay, you guys good? Yes.
This graph just taught us a rule where you can like draw a graph and get the difference between not continuous.
Correct.
Is that still applying calculus or does
It does, but think about how you're drawing your piecewise functions. Okay. After your graph is complete, yes, that is true. Okay. So you guys good? I think I have to stop this just because I'm at minute 12.